At this point, I'd like to say something about different ways of expressing volumes in biology and in kind of biological chemistry type things. So in A-level chemistry, if you did that, you probably spoke about concentrations per decimeter cubed, if you're talking about molarities or something like that. But in biology, we prefer to use litres than decimeter cubed. You'll never hear one of your lecturers say this, I shouldn't think. And what do I mean by a decimeter cubed? So decimeter is 1 times 10 to the minus 1 meters, and so it's that in each direction. So 1 times 10 to the minus 1 meters times 1 times 10 to the minus 1 meters times 1 times 10 to the minus 1 meters. So a volume is always, you can think of it in 3 dimensions, or like, so it's a decimeter cubed, so you can imagine a cube, imagine it drawn a little bit better than that, but in each of the 3 dimensions of the cube, 1, 2, 3, in this case, each one of these sides is 1 times 10 to the minus 1 meters in length. Now there are other volumes as well that we use in biology quite frequently, so we've got a milliliter, and that's equal to 1 centimeter cubed. So in that case, that's 1 times 10 to the minus 2 meters on each side of the cube. Okay, and that gives us 1 milliliter, which is 1 times 10 to the minus 3 liters. And then the other main one that we're going to be talking about is the microliter, which is 1 millimeter cubed. So that's 1 times 10 to the minus 3 meters on each side. So to get a volume, you're just multiplying the 3 dimensions, and in this case it happens to be a cube, but it could be a funny shape as well, as we'll see in a minute. So here, so to get there to there, this is going 10 times smaller in each direction, in each dimension of this cube that we're imagining. Whereas here, this is 10 times 10 times 10, or 1,000 times smaller. That's 1,000 times smaller volume. So I think these are definitely worth learning off by heart. You need to know that. Alright, so somewhere where you're going to have to think about volumes and the relationship between litres and meters are when we're dealing with cell counting chambers. Or they're also called hemocytometers. So they're invented to count blood cells. That's why they've got that name, but we can use them to measure bacteria or algae or all sorts. And this is what they look like. And you've seen one in the lab by now. So here's the slide. It's quite a thick glass slide with a cover slip on it. And the important thing I need you to remember here is that it's just the area over the top of the counting grid. So it's just this little piece that we're interested in the area of. This is the volume we want to know. So it's not, so we've got these reservoirs here. It says overflow here. We don't care about them. So we might put a volume of 10 microliters, for example, into the thing, but it's only this very thin piece in between the cover slip and the slide over the top of the counting grid that we're interested in. And that's a really important point, and something that people often get confused by. So typically, we might have a volume of something like maybe 0.1 millimeter in depth. So that's this piece here. and maybe 1 millimeter by 1 millimeter is the size of this counting grid. So therefore the volume of that contains the cells that we're interested in is 0.1 millimeter times 1 millimeter times 1 millimeter. So that would be 0.1 millimeter cubed, and so that is equal to 1 microliter. Sorry, 0.1 microliter. Okay, so that's the important point here, is we're multiplying these three different dimensions in millimeters, and we end up with a volume in microliters that contains the cells we're interested in. So that's not, we don't really care about the volume that we pipetted into the hemocytometer, because most of that just goes into the overflow, and we don't count that.